All right, I'll actually put the answer up here. This is looked up. This is the mass of the Earth. The mass of the Earth is equal to 5.97 times 10 to the 24th kilograms, and that's rounded, of course. And then let's go ahead and see how we could possibly find this mass of the Earth by considering the universal law of gravitation and looking at what we already know is the force of gravity. So imagine that you have the Earth here, and that you have a person or some other small mass there. Okay, what's the force of this on this small mass?
mg.
We know that it's mg downward, right?
Mm-hmm.
Okay. Well, this can be thought of also as the attraction between two masses, right? The gravitational attraction between two masses. So this mg has to also be the universal law of gravitation force between two masses. So that mg is going to be equal to g, mass of the Earth, mass of the mass. And how far away is the distance from here to here?
Is that the radius?
That'd be the radius of the Earth, wouldn't it, if it were on the surface of the Earth? So this would be radius of the Earth. So you have radius of Earth squared. Now, did anyone look up the radius of the Earth?
6,371 kilometers.
Very, very good. The radius of the Earth is 6,371 kilometers. What's that in meters?
Have no idea.
Yeah, so each kilometer is 1,000 meters, right?
Yeah, 6.3.
So that'd be 6.371 times 10 to the 6 meters. Okay, is that clear how I got that? So this is 6.371 times 10 to the third kilometers multiplied by 10 to the third with that. All right, let's go ahead and see if we can, well, look at this thing here. Each of these, this is an equation, each of it is proportional to that little m. So I could divide through this equation by little m, couldn't I?
Yes.
Go like this. Doesn't even, and so it didn't really matter what that little mass was. So I know what g is. G is 9.8 times, just 9.8 meters per second squared. Actually, I mean, it's 9.81 really for gravity, but we'll leave it like here, okay? The reason it's slightly less on haze is because the Earth is rotating and we're actually spinning. So, you know, like on a merry-go-round, you kind of want to spin outwards a little bit. So let's go ahead and just substitute this into here and then see if we can solve for this. Okay? Well, actually, let's solve for this first. What should we do? G is the radius of the Earth squared, right?
Mm-hmm.
Divided by big G is equal to the mass of the Earth. All right, we know everything. Big G was 6.67 times 10 to the minus 11 meters squared per kilogram squared. And we just substituted it. Times 1 times 10 to the 6th squared over G. I know that the units will be in kilograms. All right, what do we get?
I got 5.96 times 10 to the 24.
I actually wrote this as 9.81, get exactly that.
Um,
In fact, that, by measuring gravitational force, that's how they measure mass of the Earth. So, anyway, you just weighed the Earth by knowing how much you weigh. And what the radius of the Earth is. And you can get radius of Earth by looking at how far away the horizon is. For instance, I'll just illustrate this. Say you have the Earth here. Say you have an ocean and you have a person standing up here. This person is looking at like a tower or something like this. You know, they can only see like this. So you would not be able to see that far down on the tower. This is actually the place where the horizon is. And so by knowing how far away the horizon is from here, well, you can get like this. If you know this distance and you know this distance and you know what this distance is, that turns out to be sufficient to give you what the radius of the Earth is. That's a geometry problem. We won't do that here. But that's how they measure rate. You know, that's how they were able to do all of this stuff and get mass of the Earth. Okay. And of course, you can also figure out mass of the sun, all that other stuff. But we'll deal with that when we do circular motion.
How do they get the radius of the sun?
What's that?
How do they get the radius of the sun?
Well, we know how far away the sun is from us. There's that's a good question. Yeah. The independent measurement of how far away the sun is might be a little tricky. But you know, once you know how far away it is, then of course you know the size in the sky, and then you can just do look at that angular size and you can get how wide it is across.
So would you use the same equation to figure out what the mass of the sun is?
Yeah, you could. I mean, once you know how far away you are from the sun and you know the force on the Earth, it'd be pretty easy to get mass of the sun. And we will know that because we know what our period is around the sun. But we'll deal with that. By the way, homework for next week. Go ahead and finish up chapter 2 problems. Okay?
So 2.7.
Yeah,
8.
so 2.7 through 2.10. And then we'll start in on circular motion. So go ahead and do 3.1 and 3.2. So finish. That'll be due next month.
Not too fast.
The week down.